Okay, now we're moving on to exercise 4. Right, from exercise 3, if you noticed, if you've been watching my videos one after the other, I hope that you're practicing in between. But if you're watching them one after the other, you would have noticed that I didn't make a video for answer E. I'm going to put the answer for that one on the group as a PDF document, okay? All right, question exercise 4. We're now moving on to the other shapes. So exercise 2 and 3 had to do predominantly with parallelograms. And then if you remember very carefully from the diagram that I introduced to you guys in the beginning of the beginning of this topic, we were I said we have a piece of clay and we molding that shape into other shapes, thereby giving it different properties. Okay, everyone has their diagram in their book. I drew it for you guys on the board, and then we were filling in all the different properties on there, right? And then remember I told you guys that the parallelogram is the most important shape, and from that parallelogram we can shape the rhombus, and we can do that by giving the parallelogram equal sides, not just opposite sides being equal. Okay, we can also do that by giving the diagonals to meet at 90 degrees. That's another property of a rhombus, right? Or alternatively, if we don't make it a rhombus, if we take our parallelogram and give it 90-degree angles, then we would get a rectangle. Okay, we also remember that the rhombus, I even told you guys in class that the properties of a rhombus and the properties of a rectangle combined gives us the properties of a square. I said it's like the rhombus and rectangle had a baby, so it got the properties of rhombus, properties of rectangle, and the square we said has all sides equal, the diagonals intersect at 90 degrees, and the angles are all 90 degrees. So those are very important things to remember. And then in that diagram, just above the parallelogram, I gave you guys the trapezium. And then we said with the trapezium, the only thing we really know is that one pair of opposite sides are parallel. And we know that if something is parallel, then we can use corresponding angles if that applies. But it won't really apply because remember, we're not going to give you so much an exterior part of it. We're working mostly with quads, but if they give you something that's exterior, then you can use corresponding angles, co-interior angles, and alternate angles. And then with the trapezium, you can get a right angle trapezium. For that one over there, they give you one of the angles being right angle, but you can't just assume that we would give it to you as right angle. Anyway, we're using all of those properties, so you're going to go back to your diagram page if you forgot those properties, okay, in order to answer these over here. Anyway, let's proceed. It says PQRS is a rhombus, so automatically I know, let's fill it in color, all sides equal. Right, that's one of the properties. I also know that opposite angle, so this angle equals this one here equals this one over there. I also know that this side is parallel to this side, so can you see the Z? So this angle here is going to equal to that one over there, right? And if we go the other direction, so you follow with me like that, this one over here is going to equal to, wait, where did we go? This one over here, like that. Okay, we know that the sides are parallel, but I'm not going to okay, let's fill that in. It's just that is parallel to that side parallel to that side. There we go. Right, using all of this information, it says we need to calculate the size of the other interior angles. That means we need S1, we need this was a Q, Q1 and Q2. Okay, let's fill this in. I'm going to start with the one that we know is equal to this 32 degrees, which is Q1. So let's start over there. So we're going to say Q1 equals 32 degrees. How do I know this? Alternate angles. Here we go. I wrote my full reason how I know this. Okay, once I get that, I'm going to fill this in. Okay, let's fill it in over there. This here is 32 32 degrees. Right, what else do we know? We know that, what's this? We know that a diagonal of a rhombus bisects the angle. Okay, so that means this whole angle is basically cut in half. So that means angle S1 is also equal to 32 degrees, and in this case here, angle Q2 is also equal to 32 degrees. If you didn't realize that, can you see that we have a triangle over there, and this side and this side are equal, so that means the opposite angles also have to be equal. There's that rule that says angles opposite equal sides, so you could use that as well. Let me say both of these are using the exact same reason. That's why I've put it together, okay, for the same reason. You can write out the reason twice if you want, or you could even use Q2 with the alternate angles reason. Now we need to figure out P and R. We know that they're going to be equal, so that means I just need to figure out one of them. And do you see that we're in a triangle? So I can say P plus 32 degrees plus 32 degrees adding up to 180 degrees, because sum of interior angles of a triangle. So let's do that. Okay, so therefore angle P is equal to 180 degrees minus 32 minus 32, 116. Okay, and then we know P, we said, is equal to R. And there we go. We figured out all of the interior angles of this particular rhombus. Okay, next question. It says diagonals AC and BD intersect at E. They're telling us it's a rectangle, so we know all the properties of a rectangle apply, with AC equal to 10 centimeters. Okay, so this whole length over here is 10 centimeters. Therefore, this part here is 5 and 5 because they bisected. It's a rectangle, and one of the properties are that the diagonals are bisected. And BC, so this whole length over here, being 8. If this is 8, the side opposite it is also 8. Okay, then it says angle D2 here is equal to 20 degrees, so D2 is here, so 20 degrees. Okay, it says calculate, and there's quite a few of them. Generally, when we do this, you can go in any order that you want. You don't have to start with A1. But in most cases, when we give you an order, when we tell you solve for X, Y, Z, most times, if you solve for X, you use that information for Y. You can use that information for Z. But let's say you solved for Y first and then X and then Z. That is perfectly fine. In Euclidean geometry, as long as you have a statement with a proper reason and you calculate it and your answer is correct, that is perfectly acceptable. But anyway, I'm going to be following with this here. It says A1. Let's see, is there any information from this diagram that can help me with A1? Okay, what do I notice? We know that this whole angle over here should be 90 degrees, 90 degrees, 90 degrees, 90 degrees. Okay, let's see. Can I figure out A1 immediately? No, we cannot figure out A1 immediately. What we can figure out is B1 being 20 degrees. How do I know that? There's my Z. So I know that this here is 20 degrees. So let's start over there. I'm going to say B1 equals 20 degrees, alternate angles, AD parallel to BC, because those are the lines between which these angles lie. How do I know that they parallel? There we go. It's a bracket. Okay. Do you notice how I'm filling in information as I'm going along, and you can use your color pens for this, right? Now that I know that this one here is 20 degrees, because this whole angle is 90 degrees, I can figure out that B2 is actually 70 degrees. So let's write that part down. B2 is equal to 70 degrees. Complementary angles. How do I know they're complementary angles? Okay, here we go. Right, now that I know that this one here is 70 degrees, I also know that this one here is 70 degrees, same reason. D1. Okay, so we figured out that one over there. Now we need to figure out, let's see, A1, A2, C1, and C2. Okay, we know that the diagonals of a rectangle are equal. With a parallelogram and a rhombus, they're actually not equal. So if this here is equal to this here, and this one here gets cut in half, meaning this side here equals this side, it's going to equal to this side and this side. Okay, therefore, can you see the triangle? Okay, and because there's a triangle, can you see that this one, with equal sides, this angle here is going to be 70 degrees as well. Okay, or alternatively, we could have worked with our alternate angles again if you wanted to. Let me just see if it works out. Okay, no, not that way. Which way? Oh no, it doesn't work out in this case. So we're going to go with what I said the first time. So we're going to say angle, we're going to say AE equals EC. Okay, in triangle EDC, ED is equal to EC. Okay, therefore D1 equals C1. Okay, I'm also going to mention exactly which sides are equal. We said ED equal to EC, and that's listed already above here with its reason. Okay, now that we know that this one here is 70 degrees, we now know C2 is 20 degrees. Reason for this, complementary angles. Okay, how do we know this? Okay. And then once we know that this one here is 70 degrees, see our Z, A1 is equal to 70 degrees. I'm going to continue on this side. Okay, and then if we know that this one here is 70 degrees, we now know that this one is 20 degrees. Okay, that's a bracket. There we go. So we figured out all the angles that they wanted us to figure out over there. Now we need to figure out lengths of AD, AE, and AB. AD, we already mentioned this, is equal to 8 because opposite sides of a rectangle are equal. Okay, and then we need to figure out AE. Okay, we already said this. This is equal to this, is equal to this, is equal to this. So we're going to say it here. AE equals 5 centimeters. And because we already wrote a proof for this over here, okay, there it is, diagonals are equal and bisected, you can just say proven above, because you already wrote a proof for it. Okay, if you didn't write this statement, then you're going to have to show this part and this whole reasoning again in order to figure out how this here is 5. And then we need to get AB. Okay, so AB is this one over here. Now to show you that we actually have theorem of Pythagoras. We have this here to be 10. We're looking for this side here, it's unknown, and we have this length over here to be 8. So do you see theorem of Pythagoras with a right angle over there? So we're going to say in triangle ABC, AB squared equals AC squared minus BC squared. I took the hypotenuse squared minus the side here squared to give me that side there. I'm going to write Pyth because that's the reason. Okay, I'm running out of space on my page. Continuing over here. AB squared equals 10 squared minus, what is it, 8 squared. Okay, this is what it gives me, but we need the square root of it. Okay, we knew that there. So AB equals 6 centimeters. There we go. So we used all of our what's the word? Properties of a rectangle to answer this question over here. And for this one here, all the properties of a rhombus to answer that question over there. Please, you need to know all of your proofs in order to answer these things. You also notice how we put full reasons for everything. I don't just write property of rhombus or property of rectangle. I state which property of the rectangle I'm using and how I know that. Okay, so please, I want you to do the same thing in your test.